So, okay, so yeah, today is all about limits. Actually, all of chapter 2 is limits. All of chapter 2 is limits. And so I'm going to argue that we're not really starting even calculus until chapter 3. So the assignment that is due today is the 2.1 assignment, and this is on an intro to limits. All right, well, what is a limit? The idea of a limit, in fact, the way that the notation for a limit looks like this. I have the limit as x approaches some value. Say that it approaches 3. And then we have some function here of our f of x. I'm going to call that, we'll just call that, how about 2x plus 1. And then I want to know what that equals. So this isn't, let's make it very, very clear that I'm not saying x equals. I am not saying x equals 3. I'm saying what? What does that arrow mean? Approaches. I'm saying x approaches 3. When x approaches 3, what does our function do? Well, in this case, there's nothing wrong about taking this 3 and plugging it right in. I'm not violating any rules of math. And so it turns out that the answer to this is the same for in this case. In this case, the answer is going to be the same as if f of x equals 2x plus 1, and I'm trying to find f of 3. In this case, it's the same. What's the answer?
7.
The answer is 7. I plug that in, I get 6 plus the 1 is 7, and so we get 7. Now, there are some situations where we never get to that value. Like, for example, let's look at the limit. Let's use, I'm not doing very well. Here's my example. I have the limit as x approaches 0 of 3 over x. If I plug this in, what's the problem? Yeah, so if I plug that in, I'm going to get 3 over 0, which is undefined. But 3 over 0 is not what is called an indeterminate form. An indeterminate form is a form that is not determined. So because 3 over 0 is determined, we already know it's what? Undefined. Then this is going to, we just say, does not exist. What doesn't exist? I'm saying does not exist. What doesn't exist? I'm saying that the limit as x approaches 0 does not exist. The limit as x approaches 0 for this function does not exist. Now I use this word indeterminate and determinant, and let's explore this. When we have something, bless you, what is it? Let's see if I can find our list of determinate forms. Our list of determinate forms or indeterminate forms would be, bless you, indeterminate forms are 0 over 0, infinity over infinity, or infinity over 0. These are indeterminate forms because as I approach these values, then there could be a limit. They're indeterminate because there could be a limit. Here, this is not an indeterminate form because 3 over 0 is just clearly just undefined, so it does not exist. So let's look at an example where I would get an indeterminate form. If I have something like this, I have, here's my example. I have the limit as x approaches, let's make up one. X squared plus 8x plus 15 over x plus 5. I think that one works. So what happens? Read this for me. What does this say? At least what does this say?
Limit as x approaches -5.
-5, yeah. So the limit as x approaches -5. What is the limit when x approaches -5 for this function? If I plug it in, do I get an indeterminate form?
No.
Let's plug it in and find out. -5 squared plus 8 times -5 plus 15 over -5 plus 5. In the numerator, I have 25 minus 40 plus 15. Does that look right? Over -5 plus 5. What does that give us in the numerator and denominator? What? Louder, please. 0 divided by 0. That's an indeterminate form. What does an indeterminate form mean?
That's it. Fully calculated.
It's not determined. Just when I have 0 over 0, the limit is not determined. If I have 3 over 0, is that indeterminate?
No, it's undefined.
Yeah, it's just undefined. It's clearly undefined. Now, it seems like this would also be undefined, but we don't know because it's indeterminate. So we're going to try to figure this out. So in this case, what if instead I factor this? Can I factor the numerator?
Yes.
To what?
X plus 3, x plus 5.
All right, x plus 3 times x plus 5 over
X plus 5.
x plus 5. What can I do from this point?
You can simplify with x plus 5.
X plus, we can cancel these out, right? X plus 5 over x plus 5 is just 1. So I can simplify this to the limit as x approaches -5 of our function of x plus 3 equals what? -2. Do you see that I'm not violating any rules of math now by plugging this in? It's
It
not.
doesn't actually reach there ever, but
Yeah, in fact, let's look at it. Let's look at, so let's make sure we understand this. I'm saying that when x approaches -5, what does the y approach? And I'm going to graph this and we're going to look at it. So I'm going to go to Desmos. And my function is y equals, just folder places right now. So this was x squared plus 8x plus 15 over x plus 5. And it just looks like a linear function. Now let's look at, what did x approach? What did it say? -5? All right, so I'm going to,
I thought it was -5.
oh, sorry, what did x approach?
Oh, at -5.
-5. So I'm going to approach x equals 5. So there's x equals 2.98.
-5.
Oh, -5, thank you. Okay, let's go back over here. -5. So here's negative 4.86. And if I continue down, oh, I passed it. You guys see that? What does it say? What does Desmos say? That when x is -5, it's undefined. Now, am I saying x equals 5?
No.
I'm saying x what?
Approaches negative.
Approaches -5. When x approaches -5, what does the y approach? Can you see if you go across to the y-axis? -2. Is that what we calculated?
Yeah.
Okay. This is really important that we understand that this means, this notation means approach. X approaches -5, right? So let's continue. Let's explore this equation that looks like they have y. So I have the limit as x approaches 0 of sine of x over x. Now, this is something you're going to have to memorize, what the answer to this is. But we're going to explore what the answer is by doing another method. One method, of course, is by factoring, see if we can eliminate something and see if we can plug in our value into what the result is after we've eliminated values. That's certainly one strategy. Another strategy is if we're looking at when x approaches 0, well, let's look at it. Let's look at this using our calculator. So let's come up with some values. Here's x, here's my f of x, assuming that my limit, this is the limit as x approaches something of our function, right? That's how we write a limit. So get rid of that. So here's my x value and my f of x value. And we're going to look at what happens when we get closer and closer to x equals 1. So here's 1, how about 0.1, how about 0.001, 0.001, 0.0001. When we take these values and we plug it in, if I plug this in using your hand trick, what is sine of 0? What is sine of 0 degrees?
No.
0. And then we have 0 over 0, which is what? It's indeterminate. We don't know what the limit is because this is indeterminate. It's not undefined. Why is it not undefined?
Because both the top and bottom.
When I have a 0 in the numerator and denominator, we don't know, it could be undefined, but we don't know that. It's an indeterminate form. If I have this, Bentley, I think you have a good.
Oh, I meant to say undetermined, so.
Oh, okay.
So I
It-
just screw it.
Oh, it's no problem. But if I have a value like 3 over 0, then we can clearly say at this point, no, this is the limit doesn't exist. We can just jump to that conclusion really quick. But if I have one of the indeterminate forms, and in this case I have the 0 over 0, then there could be a limit. So we need to explore that. So let's see what happens when we get closer and closer and closer to 0. Why can't this just be 0?
Because indeterminate.
It's indeterminate. It's an indeterminate form. So we're going to see what happens when we get closer and closer. All right, so let's plug in. Everybody have a calculator? Anybody have a calculator? What happens when I plug in 1 here? Sine of 1, make sure that this is a calculus class, so what should your mode be in? It should be in radians. We're not using degrees in this class. If you plug in sine of 1 over 1, what do we get? What do we get? What is our y value? Okay, so I'm getting, so 0.8414, something like that. It's probably an irrational number that just continues on without a pattern. Okay, what if I plug in 0.1 into these two here? .99, okay. So we get 0.9983. What if I plug in 0.01? Yeah. So we get 0.99983. So we're getting closer and closer to 1. So what's the limit for this? Yeah, it equals 1. Yep. Now I have to admit that when you deal with trigonometric functions, it does get confusing because these oscillate back and forth. And in fact, let's graph this and see what it looks like. But this is something you're going to have to memorize. This would be your first flashcard in this class, that the limit as x approaches 0 of sine of x over x is what? This is 1. This should be your first flashcard in my class. That is something you have to memorize. Do you get a formula book for this class?
No.
No, you have to, everything has to be memorized cold for this class, for your AP test. So I'm going to graph this. We can see what that looks like. So this is the confusing part, because if I have y equals sine of x over x, we have this oscillation. So what are we, when x approaches 0, well, here's x is negative 1.42. When I approach x equals 0, I'm approaching 1, but we see that there's a hole in our graph right there. So this is something, in fact, all of the trigonometric, there was a theorem, the sandwich theorem. I'm not going to teach the sandwich theorem because you don't really have to worry about, this is, in this class, you won't have to worry about the sandwich theorem. What all of the trigonometric functions should be simplified to something like this.
All right.
And once you simplify that, then that just becomes, it just becomes 1. Just make it 1. You can simplify your trigonometric functions to this, just make it 1. And then figure out the limits for the other part. All right, let's do another one. Okay. If I have the limit as x approaches 3 of x squared minus 9 over x minus 3, I want to give you some think time. You should have the skills to figure this out. Now I understand that there's a learning curve, so these things are still complicated. So even if you don't get the answer, it's fine, but I do want you to try to get the answer. Tate, did you get the answer?
That would be 6.
It is 6. How did you get 6?
Well, the numerator is a minus squares. Subtracting some squares.
Different squares.
Different squares.
Okay, so you're seeing this as a difference of squares. I agree with you. So if we remember our rule for a difference of squares, then we can factor this to what?
X plus 3 by x minus 3.
Yeah, so x plus 3 and x minus 3, all over x minus 3. Then what did you do? X minus 3? Okay, so we can simplify this limit as the limit as x approaches 3, oops, not equals yet, of x plus 3 equals what? Just plug that in, right? And that gives us 6. So what does that mean if I graph this? If I graph this as y equals x squared minus 9 over x minus 3, we get something that looks like, this my y equals x mx plus b. So I have a slope of 1 and my y-intercept is what? I graph this. It's linear. So yeah, 1, 2, 3. So I have, and then a slope of what? 1. So y equals mx plus b, a slope of 1. And so it should look more or less something that looks like this. But there's another important feature on this graph if I graph this. What is that feature? What's that?
X can't equal 3.
X can't equal 3. So at 3, so 1, 2, 3, there is a hole in my graph right here. So I don't know if I could just do a little circle here, like that, something like that. Okay, there you go. That's what that graph looks like. There's a hole there. And the corresponding y value when x is 3, oops, wrong tool. Let's go back. If this is 3, the corresponding y value is louder? 6. Yeah, we figured that out to be 6. Yeah, the corresponding y value would be 6. Okay, nice. Here's another example. The limit as x approaches 1 of 3x squared plus 5. Anybody? Yes, sir, Thomas.
8.
Does everybody else have 8? How did you get 8?
Well, in this case, you can see that it's a continuous graph. And
Yeah, there's no hole. So I just take that one, plug it in, and that gives us the answer. 1 squared is 1 times 3 is 3 plus 5 gives us 8. We good with that?
So there is no hole?
There's no hole in this one
Why?
because there's no limitations, right? Here, if I look at here's my equation right here. That's my function. And if this x here is 3, then 3 minus 3 is 0. And I have in fact, let's see, is this indeterminate? Is this indeterminate? Let's plug in our zeros. If I plug in 0 here and 0 here, oh, sorry, it wasn't 0, it was 3. It was 3. I apologize. It was 3. If I plug in 3 here and 3 here, does that give me 0 over 0?
Yeah.
Yeah. So this is an indeterminate form. And if I do that here, is this indeterminate?
No.
No. It's not indeterminate. I know this has a very, in fact, this is the same. It turns out that this is the same. If I have some function of f of x equals 3x squared plus 5, and I'm trying to find f of 1, then that's going to give me the same answer as this. But that only works if you have a case where there's no hole. Otherwise, this is not true. So I plug this in, and there's no violations of math, and I get 8. Okay, in fact, we know what the transformation of this is, right? What's the transformation? If this is, what's our transfer? What does this 5 do? Yeah, we have 1, 2, 3, 4, 5. So we have a parabola like this. What does this 3 do? How much does it vertically stretch? By a factor of what? Factor. Yeah. Yeah, a factor of 3. So there's no hole. It's just a quadratic. Yes, sir.
what happens if you try and keep the limit of something that isn't a function?
If you take a limit for something that isn't a function, then it would not exist.
All right, cool.
So if I have something like this, and I want to find the limit, so this is my x equals 3, okay? And I want to find the limit when as x approaches 3 of this function. I want to find the limit when x approaches 3 of this function. Well, when I come over here, 1, 2, 3, there's infinite answers. So I say that I'm not approaching anything. When x approaches 3, there's nothing that my y approaches.
It exists everywhere.
So you say that doesn't exist. You're not approaching anything.
Cool. Thank you.
You're welcome. Good question, though. All right, so let's look at, so you could have a limit for something that's not a function. You could have a limit on that equation where you don't have more than one y value. Right, so like something like this, a circle. So I wouldn't have a limit anywhere except for this point here and this point here. Okay, let's move on. Let's do another one. A limit as x approaches 1 of x minus 1 over x squared minus 1. Think time. Throw another one in there. Where's Carter? Carter, is this indeterminate?
The first one, yes.
Okay, and so you have a 0 over 0?
Yeah, not zero.
Okay, so if it's indeterminate, it means I could have a limit, right? Carter, did you find the limit?
I was close there.
Okay, so Mr. Hall, have some patience. Okay, I'll give you some time. Winnie, do you have the first one? Is the answer what? It's not 2. It's 1/2. How did you get it? Who said 1/2? Awesome. Tate, how did you get 1/2?
Oh, the denominators, different squares,
It's a difference of squares, right?
so it's x plus.
We could write it like this, right? We could write it like that. 1 is the same thing as 1 squared, right? Tate?
Yes.
Okay, so that's the difference of squares.
So it's x minus 1 over x minus 1 times x minus, well, x plus 1.
Okay,
Simplify the x minus 1. 1 over x plus 1. I'll get 1, get 1 over 2, just half.
yeah. So are we good with that? Okay, you want some more think time for the next one?
Yeah.
Okay. Where's Maya? Maya, do you have this one? What did you get?
And then cancel out the x plus 1, so then have x plus 2. So that'll be
Yep. What?
and then that's just 1.
Yeah, the answer is 1. The answer is 1 for that one. Would it help if I graph it? Do you want to see it graphed?
Sure.
Okay, let's see whether this is true. Let's go to Desmos. Clear that. So my function is, and just for a placeholder for now, it's x over x, and then so I have x squared plus 3x plus 2 over x plus 1. Did you determine, was this indeterminate? If you plug in -1, do we get 0 over 0? Okay, cool. Now what happens then? We found out the answer is 1. When x approaches -1, right there. Oops. We can see it's undefined, but if you go across to the y-axis, what do we get?
1.
We get 1. So the answer should be 1. All right, and next one. The limit as x. Yes, sir.
Is the identity of the people who first discovered these known?
So what?
Is the identity of the people who first discovered this unknown, or is it known?
I thought it was Mr. and Mrs. Limits.
All right.
I'm just joking. I don't know. I don't know. No, I don't know. I guess there's a lot of, I think that the history of math is absolutely fascinating. And the whole idea of, have we talked about where calculus came from, for example?
I was
Okay. Well, calculus was, there was a guy, this physicist, and he really wanted to try to figure out, or he had some ideas, some theories on like planetary motion, but the math that existed at the time didn't exist. And so he created his own math to prove that these laws, these laws of motion, if you will, were actually true. Now, this guy's name, any guesses what his name was? Isaac Newton, right? So Isaac Newton came up with this and this law, the calculus. He didn't care about the calculus. In fact, he didn't even publish it. He cared about his laws of motion. And it wasn't until another guy named Leibniz, a German, published the first book of calculus that Isaac Newton, he got outraged. He's like, what? Wait a minute, those are all my ideas. I came up with those. So he quickly published a book called Mathematica Principia, the principles of mathematics. And, but that was after Leibniz. So today we look back and we give both of them credit for calculus. But I have my bias that I think maybe Isaac Newton was the first one to come up with it. So anyway, let's look at this one. So I love the history of math. I think it's really fascinating. But I don't know everything. I don't know all the histories of everything. Some of the things are like, you have Pascal's triangle, for example. And it's like, wait a minute, Pascal's triangle was discovered thousands of years before Pascal. So is it really Pascal's triangle? Is that history flawed somehow?
Yeah, the story, just look at that, like people who might have made that. All right.
Everything's better. In fact, well, and it's actually, we are made up. We don't actually exist because we're in the matrix, right? Oh yeah. Okay. Sorry. The probability that you're a real person is 0. And I can show the math. What's that?
Probability isn't a thing either.
Okay. Well, then that throws everything out the window. Okay. So let's look at this one. Sandwich theorem? No, we don't do the sandwich theorem. Everything is going to go back to that one equation that I gave you. What was that one equation that I gave you? Sine of x over x equals what? 1. Is there some type of mathematical tweaking that I can do here to create this? Now remember, x is just an angle. So in fact here, this is 2x is just an angle. There's something I can do. This is just an angle. Is there something I can do to this, manipulate this somehow, not violating any rules of math? So I get something like this, so that equals 1, and then whatever is left over is our answer.
Transform it to be, well, not transform, but factor it to be the sine of 2 times the sine of x.
I'll give you a hint. I'm going to multiply by 1. I want to multiply by 1. No. X over x will give me x squared. What's that?
1/2?
No.
Like 1 in the form of
1/2 over 1/2. No. Actually, I wonder, yeah, actually, no, because that's not the same thing. You can't distribute into here. If I multiply by 1/2, then this becomes 1/2, right? That's my vertical stretch, not my horizontal stretch. I'm going to multiply by 1/2. Oh, sorry, I'm going to multiply by 1 in the form of what?
Okay. All right, sorry, close.
What do you hate about 2? What do you hate about 2? Why do you hate 2? I'm multiplying by 1 in the form of 2 over 2. How does that help? What do I have to do with, is that 2 part of my horizontal stretch or my vertical stretch? It's my vertical stretch. So that's going to give me, if I multiply by 1 in the form of 2 over 2, that gives me the limit as x approaches 0 of 2 times sine of 2x over what?
2x.
What if I draw my parentheses? Can I draw my parentheses? Is this allowed to draw my parentheses like that?
Yeah, wait, no.
No,
No.
yeah, we have to take the 2x on the bottom.
Yeah. you gotta do
Why?
both top and bottom. You can't just do two at a time.
Because you are multiplying by 1, it's that.
Okay, I have 5 plus 3 over, well, we're multiplying. This is all multiplying. Isn't this like, so if I have 5 over 3 and I multiply by 2 over 2, then that gives me 10 over 2. Can't I, oh, let's do this. 10 over, multiply by 2. So that gives me 5 times 2 over 6. Can you do that?
It's fine right now, but,
Why can't you do the same thing here?
well, because
Because
we're
you're
trying to
parentheses
use the
around
count.
the bottom.
Oh, yeah, here, too much. Okay, Bryn, what, why?
You're putting the parentheses around the bottom as well. But it's both the numerator and the
Okay.
denominator are in parentheses, but it has to be only the numerator.
Well,
Okay, let's look at another thing. What if I have something like this? Okay, I have 3 over 2 times 2 over 2. And then actually I'm doing the same thing, huh? Then 2 times 3 over 4. Why can't I do that?
you can,
Then what's wrong with this?
nothing. I think the way you're explaining it would be.
You can't actually do that right here.
Why can't I do this?
Well,
Technically,
first of
you
all,
can.
we should probably take a look at it and let's do it. Let's first. do the-
Technically, you're technically just timing it by 2/1.
And you can't just do that, take that out of nowhere.
Technically, Did it,
Well-
because you took the 2 out of the
Yeah,
2
it's actually
over
legal-
1
legal
and times
comment.
it by the other 2, leaving 2 over 1 times the rest, which has now been changed.
I'm like trying to think of it. Let's say we have.
Is this allowed or not?
Yes.
Yeah.
I'm gonna say.
It is allowed. This is, I didn't do anything wrong.
No, I'm looking at it, right? So let's, we have a 3 times
Okay.
times 2 over 2, right? And so we're going to multiply this in, and we end up with, so let's say that sign just completely not signed, that 2x, let's say it equals 3, right? Let's say 2x equals, or let's say x equals 2, right? So we have 3 halves, right? Then we're going to multiply that by 2 over 2, like we did there, right? 2 over 2, right? Now let's just do this right here, so we have 6 over 4, right? Yeah, that's what you're gonna end up with, and so if you do the same thing where you end up with a 2x, so if you're multiplying, instead of, so you have 3 halves times 2 halves, instead of having this, you have 2 times 3 divided by 2 times 2, which would equal 6 over 8, which is not equal to 6 over 4. It's 6 over 8. I'm
2
confused.
over 1, it would be 2 over 1 that you're really multiplying.
Oh, does that help? Would you be more happy if I did that?
Whole number, your actual number
Are you guys more happy with that?
Yeah.
is over
Okay.
1.
Technically, you could just pull the 2 back out of the x and put it back.
Okay. So are you good with this? Yes, no, maybe so.
I have more questions.
Yes.
Sorry about this. but,
No, this is important.
So look at this, you have, you're saying that 3 halves times 2 halves equals 2 times 3 fourths. Can you just like multiply those and show me your work?
Okay.
Like together, start with 3 halves times 2 halves, right?
Okay,
You
so-
end up with 6 fourths, right?
You get 6 fourths, yes.
Yeah, and then you multiply 2 times 3 fourths, what do you get? No, 2 times 3 fourths.
Okay,
Oh,
two of these 3 fourths.
Oh, wait a minute. No, these are good for a reason. Listen to this.
Okay, are we okay with what I did? Thomas,
Yeah, I'm comfortable.
my wife was in a chemistry class and they just a side note, the teacher was saying, so when you boil an egg, and then my wife, this is in high school, right? And she just got it fixated with that. She's like, "No, you can't boil an egg." And so in her mind, she's thinking of like scrambled eggs or, you could do sunny side, which is sort of, what's that, fried egg. but she wasn't making this connection of like a hard boiled egg. And so it just freaking her out. So that's where it's like the stop all of a sudden.
You could just crack the egg and boil it that way.
For sure.
That'd be disgusting.
For sure. That's a poached egg. Okay, my point is it's actually part of the learning curve. When you get pushed with your knowledge, sometimes, you know, for a brief moment, it's like something else came out. I learned this piece, but this piece came out. So Thomas, you're fine. I'm thoroughly impressed with you, so don't worry about it.
If you didn't know, I'm actually smiling extremely largely underneath this mask. I love you now.
Awesome. Cool. All right. So what can we do from here?
Well,
Now we're about to talk about the properties of limits. And this is really important to understand with the properties of limits. This can actually be separated to be this, where I could have, let's make sure I'm using the right tool here. I can separate this to be the limit as x approaches 0 of 2 over 1, or just 2, times the limit as x approaches 0 of this sine of 2x over 2x. They're the same thing. That's one of our properties. We're about to go over all of the properties. Are you comfortable with how I broke this up?
Yeah.
Then what does this piece become?
What?
Yeah. Isn't that just sine of an angle over the angle?
yeah.
Yeah, so that's just one. What is the limit as x approaches 0 of 2?
2.
Yeah. Well, let's graph it. Y equals 2 is this line 1, 2 here.
Whoa.
In previous years, the most constant.
When x is 0, what is y? 2. What's that?
Next is anything.
When x is anything, it's 2. Correct. So that gives me 2 times what? 1 gives me 2. So you're not going to have to do the sandwich theorem. Thomas, all the trigonometric functions, they can all simplify to somehow go back to this here.
I'm gonna use it if I want to.
Yes.
Very cool.
What's the limit on this one's 2?
The answer is 2. Do you want me to graph it?
Yeah.
Okay, let's do it. So let's go to anything you want me to graph. I'm here for you guys. And if you feel like that's going to give you a deeper understanding, I want you to ask. So I have the sine of our angle of 2x divided by x. Isn't that it? Was that original?
Yeah.
Yeah.
So when x approaches 0, y approaches 2. Yep, correct. Is this indeterminate?
Yes.
Do we get 0 over 0?
Yeah.
Yep. So we had to figure it out a different way. That is something, this is your first flashcard. Go get a pack. Don't they come in like hundreds? Or like a pack of 100 flashcards, index cards. I highly recommend getting a pack of flashcards. You could do this on paper. The only problem with paper is that you can see through it and see the answer on the other side. And so one side should be this, right? The other side should be 1. Yep. So, all right. I don't know if it's worthwhile to make these flashcards. I think they're pretty intuitive. These are the properties of limits. I think that they're pretty intuitive. Properties of limits. If I have the limit as x approaches c, what is c? Just some number, right? Just some constant of our function of f of x plus g of x. Any guesses? If I'm saying, Mr. Hall says this is intuitive. If it's intuitive, then what should this property be?
Then you can add the.
Yeah, we can have the limit as x approaches c of f of x plus the limit as x approaches c of g of x. Thomas, what's that?
The sum rule, it's the exact words, the limit of the sum of two functions, the sum of their limits.
Awesome, cool. Okay, next one. If I have the limit as x approaches c of f of x minus g of x, if these are intuitive, what should this be?
The limit of f of x minus.
Difference in the limit.
Yeah.
Do you guys have that memorized? Was that your instructor? Was it where did you learn that?
The video.
The videos?
Yeah.
Cool.
The difference rule. The limit
I
of the-
only, this is about where I had to stop to get to school, so.
This is where I memorized this.
I don't feel like you have to have it memorized. I don't have it memorized. I just feel like it's pretty intuitive.
Yeah.
I don't feel like it's something you have to have memorized.
You can use a separator. No, technically, you just distribute the limit.
Okay, I feel a little nervous about saying you're distributing the limit because this
Technically, you're
isn't I'm not taking this times this, right?
Yeah, technically you're not, but.
But the concept is still there. The concept is, okay, I'll give you that. The concept is still there. All right, what about this one? We have the limit as x approaches c of f of x times g of x.
The limit of the product of two functions is the product of their limits.
Okay, I do not have those memorized. I'm impressed that you do. I'm actually more impressed that some of you actually listened to me when I said, I think it's a good idea to watch the videos before you come to class. It was so cool in college. It was so cool. And because I was so intimidated. I'm taking a school law class where you have to memorize all these cases. I'm totally terrified that I'm not going to do very well in this class. And so I read the book before I go to class. And then I'm totally on fire in the class. And the teacher's talking about this. And I'm like, oh, are you talking about this case? Oh, does it end this way? And I'm being accused. The other students are saying, you must have an eidetic memory. You have a photogenic memory, don't you? So like, no, I'm just a regular guy. I thought that was so cool. So I sort of figured that one out myself. All right, so easy. Okay. There is no division. I don't think it's actually true that the division, no, it is, it does work, it does work. So we do have one that's similar like this. The limit as x approaches c of f of x over g of x equals, Thomas, what?
The limit of the quotient of two functions is the quotient of the limits provided the limit of the denominator is not zero.
How about we're good with just that it's intuitive?
Yes. It's
Okay. Gx, all right. It can't be zero. So I'll just say that. I'll say limit. Yeah, you just say can't be zero. Can't be zero. All right. So we have another one. We have the constant. Is it called the constant property?
The constant multiple rule.
Constant multiple rule. Yeah, I don't know what they're called. Thomas, you need to come and teach the class.
Yeah, sure, I will do it.
Mhm.
The limit of the constant times the function is the constant times the function. It's very confusing.
Well, what it means though is if let's talk about this. We know based upon this law up here that this can be rewritten like this. So wouldn't it also be true? Don't write this down. Don't write this down. That the limit as x approaches c of k times the limit of x approaches c of f of x equals the same thing as this. But what is this? This is always going to be what?
Constant.
It's always going to be the constant. Isn't that what we figured out earlier up here? That this part here was just 2.
Yeah.
So Bentley, what was that?
So
Bentley?
then it just be the constant times.
Yep.
Over the next.
Yep. Well, you could write it all down, but I think this is this.
Oh,
That's very right. And it's the power rule.
Did I miss one?
No, the power rule. The last one. Power rule.
I don't see the power rule.
the limit of the rational power of a function is that power of the limit of the function divided by the latter is a real number.
Am I missing one?
Yeah, you seem to be.
Ah, man, it's cruel. It's cruel.
Expect that people working 15-hour shifts will be better at teaching, but you know, you can't always decide.
Wow, brutal. Okay, so I don't feel like, what was it, Julian? I don't feel like you have to write this part down, but that's the connection that we can make to understand why this works. Or Julian, were you the one that said, can I copy what? Oh, does that make sense? Why I wrote that down? Trying to make that connection of why we can just take that K and move it to the front. All right, so I have to look at the power rule.
The power.
Apparently I missed one in my notes.
Yeah, but,
Thomas, just tell me what it is.
all right, so it's like, if you have a function.
Wait. Okay,
If you're
let's,
taking the limit of a function, that is the power of something.
okay,
like,
what,
the limit of-
Thomas, when I say wait, what I actually mean
Is there
is
more than a second?
not to talk until I'm ready.
All right,
Okay, you're sassy to me, so right back at you. Okay, let's go for it. So I have the
all right,
limit,
so if you took the limit, where x is approaching
C, okay,
c, and of a function to the power of something.
of a function to the power of something
So
about,
usually like that's k divided by x or something.
right, K. Why am I divided by X?
Because if x is 0, it's not gonna work, right?
This is K.
If k is undefined or something,
Okay, so
provided that the letter is a real number, as long as it's a real number, it'll be fine. So it's a real. Yeah. And then if you limit of all that, right?
you take the limit of all this,
Yeah, and it'll be equal to the limit of the function with that entire thing, it's to the power of k.
all this is the power of K.
Yeah, that's what it is.
Okay, cool.
They go into that stuff like k divided by s and s can be 0.
K divided by,
Yeah, they make that the exponent and s can be 0.
okay, so you can just move it out, yeah.
Yeah.
Okay,
That's what it is.
Yeah.
Hope it comes easy someday.
I don't find that one super helpful, but it is sort of cool. All right, so how much more time do we have? 20, something like that,
24 minutes.
24 minutes. Okay, I'm going to draw, let's do this. I have J of X equals -1 over X minus 1 plus 2. I want to find, we're going to use this for all the problems. We're gonna have, well, 3, I guess 3. So I have, I'm trying to find the limit as X approaches 1 of J of X. Is Anna here? Anna? No, Anna? What about Jacob? Where's Jacob? Jacob, what is the answer to this? Okay. What's your thinking process? Yeah, let's take that 1 and plug it in. What does that give us? If I plug this into here, Okay, which is? Is this indeterminate? It's 0 over 0? No, so what is this?
Does not exist.
Yeah, it does not exist. Does not exist. I'm gonna graph this. I want you to take a look at how this, what it means if our function does not exist, if our limit does not exist. Okay, I have j of x equals -1 divided by x minus 1. Now, what am I approaching? What's that? What's the problem? Oh, plus 2. Plus 2. What x value am I approaching?
Positive and negative infinity at the same time.
I'm approaching 1 when x equals 1. And yeah, you just like Bryn said, when x approaches 1, our y value goes where?
Negative infinity and infinity.
It goes to infinity and negative infinity.
Which is two things.
Yeah, they're huge extremes, right? How can you have infinity dollars, or how can you be a millionaire and be in debt $1 million? That doesn't make sense. You're going in two extremes. Those are two extremes. So we say that the limit does not exist. Jillian.
Yeah.
Why does the limit not exist when x equals 1?
Because you can't have two extremes at the same time.
When x approaches 1, you end up going in both directions, which you're not approaching anything. Do you agree, Jillian, that you're not approaching anything if you're shooting off to infinity and negative infinity? That's a good way of putting it. Yeah, you can't have every answer be your answer. I like it. Nice. So that's why the limit does not exist. All right, so we're going to do another problem. I have the same equation of j of x. Guess I'll zoom out. And I have the limit as x approaches, new notation. New notation. What the heck does that mean?
They're pushing it from the right side, but yeah. Left side.
We have this, I know what +1 means, or -1, or +1, I guess, and -1. But what does it mean to have a 1 and then a plus after it? What the heck? What? We're approaching from the positive side versus approaching from the negative side. Mariah, where's Mariah? Mariah, what does this mean, this plus after the 1? We're approaching from the positive side, and this negative? From the negative side. So which way is which? What? So here's my here's my graph. Which way am I approaching from here?
On the right side.
From which side am I going? Am I going left or am I going right? I'm going left. This one is going left. I'm starting over here on the positive side and I'm going left. What does this mean?
From the left to the right.
From the left, from the negative side over here to the right. Does that make sense how to read this?
Yes.
Okay, so the question is, so I'm looking at when x approaches 1 plus, 1 from the positive side. What's the answer?
Does not exist if it's infinity.
You're right, you could actually say, actually, no, we do say you are approaching something specific. You are approaching something specific. What's that?
Infinity,
How about negative infinity?
negative side, sorry.
So we're still approaching something. We're approaching some negative huge number, right? Or small number, I guess, in that case. So this would be, in this case, it's going to be negative infinity. The answer to that is negative infinity. All right, so what about 1 minus or negative or whatever? Yes, Brandon, what's that?
The negative side is approaches positive.
Yeah, from the negative side, when we approach 1, when x approaches 1, the y value approaches infinity. So we're actually going to say that these are our real values here. We're going to say that we have infinity and negative infinity for that. Bentley, are you good with that? Okay, let's do another one. Let's look at a graph. Here's my graph. I'm going to go to the top and start. Were you still copying, Bentley?
No.
Good. Thomas, do you see how Bentley talks nice to his teacher?
Sorry, I just say it the way it is.
You just say it the way it is. Nice. All right. We're going to say that this is 3. This is 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, let's 4, 5, 6. 1, 2. Just all right, I'm going to start over. I'm going to take a screenshot. That way Thomas has to be nice to me because it's not really my chicken scratch. I'm going to draw a graph. I'm going to attempt to draw a graph. And the graph is going to look something like all right. So I want to find the limit as x approaches -3. This is my function of f of x. What is the answer?
Does not exist.
Does not exist. Why does it not exist?
Has to be both infinite and-
Yeah, or should I? Good. We're shooting off in both directions. So the answer for this is does not exist. Okay. How about this one? Number 2. Actually, I'm going to just write a couple so you can think about these. Are you already done, Thomas?
Yes,
With all of them?
pretty sure. Yeah.
Oh, okay.
Yeah.
All right, I'm gonna give
Wait,
some,
actually, no, I'm not.
I'm gonna give some think time. Kane, more think time? Kana, sorry, Kana?
And we do one together.
Yeah. So let's look at, can I help me out with this one? What does this say?
As x approaches -2, is y approach?
Yep. So any guesses on what the answer to that is?
One.
Do you agree that the answer is one?
Yes.
Yeah, we just go over here and we find this point right here. We're not really, there's no hole there.
It's continuous.
It's continuous. So in this case, I'm saying, sure, when x approaches negative infinity, -2, but it's also when x equals -2 in this case, because that's actually continuous there. There's no hole. Because I see a hole here.
Oh,
I don't see a hole here. So I'm gonna say here that when x is -2, then our y value is right there at 1. So the answer is 1. Okay, now what about the next one?
is it just one?
It's also 1. Yeah, it's also 1. Mr. Hall, this is boring because they're all 1 then, right?
No.
No. All right, so what about Bentley? Any guesses what this one is? Read it to me first. What does it say? The limit.
The limit of when x is approaching 10 is equal to f of x. There's, because I'm not sure, but there's 2 possible answers, and it's in my mind, and it's 2 or 6. Because as the x values approach 10, they're approaching 6. However, the actual point is 2. So
Let's go back to this over here. Remember this problem right here? We're trying to figure out what this was. This is our first flashcard, right? And so we're inching closer and closer and closer to that value of 0. And so a limit is what does the y inch closer to when x inches closer as well?
6.
The answer should be 6. There's only one answer. Do you agree? Does that make sense?
Yeah.
Okay.
Makes perfect sense. I was just.
Does everybody understand why the answer has to be in this case 6?
Yes.
Okay, please explain to me, Kana, why the answer has to be 6.
Because as x approaches that, it's nearest to 6 or something?
Yeah, when we get closer, when we're inching closer and closer to x equals 10, the y inches closer and closer to x equals. Oh, right, the y inches closer to 6.
But since it's not 6, it's still 6 then?
Yeah, because we're not saying, I never said equals here, right? I'm saying that it's the limit as x approaches 10. Okay. All right, is that the same thing as this? Is this 6?
No.
Okay, this is different. This is a different notation, right?
Yes.
This says when x is 10. Do you agree that this is that the way we interpret this is that when x approaches 10, this says when x is 10. So what's the answer to that?
2.
The answer has to be 2. Yep, the answer has to be 2. Can I go back one more? Yep, the answer has to be 2. Okay. I'm gonna pick on somebody else because this is important. Where's Gaia? Gaia, why is this answer to number 4 not 2? Why is it 6? It all comes down to the definition of a limit. The definition of a limit is what is when X approaches some value, what does the Y approach? We're not asking about, I'm using this equal sign. Why? You keep on saying, Mr. Hall, you keep on saying it approaches, but then you use the word equals. Well, what am I actually saying is equal? The whole limit. I'm saying the whole limit, this concept of approaching is equal to something. Okay, confusing or not?
No.
All right. I do have some other examples. I see I have about 5 more minutes left. I don't feel like anything else that I go over. It's basically a lot more repetition of the same concepts. Not that that's a bad thing. Let's try to fit one more in. Actually, it's this really weird thing that looks like this. And I've never seen this staircase before up until this class where you have this weird image that looks like this. We have something like, wrong tool. Something that looks like this.
Oh, that, yeah. Everywhere.
Now, it's almost how grades are recorded, right? Because what is a D? A D is everything up until 70, not including 70, right? Because 70 becomes what? A C. A C minus. And then a C is from 70 all the way to 80, but not included. So we have that little circle there. Do you guys see the circle? I don't know if you see the circle very well. The circle like this. Okay. So I'm saying that there's a hole. This one right here?
Yeah.
Okay. Is that better?
Yes.
Okay, maybe this weird like thing here that looks like a key. I don't know, something like that. All right. So they use this weird notation for this. They say something like, this is Y equals the int. Is that what they say? The int. Have you seen this?
Yeah.
I've never seen this before up until I started teaching this class. I did not see this when I took calculus. So they have this weird notation and it just means the integer. So we have when the integer is 1, then our Y value is represented when here, I guess, as 1 all the way across to 1, except not including the other value. So this is our integer. So here's what I want to try to figure out. I want to try to figure out, here's number 1, the limit as X approaches, oh, I don't want to say it. This is my G of X. This is my G of X. I'm just going to write a bunch because I know we don't have a lot of time left. Bentley, do you watch the videos before you come to class?
Sometimes it was not one of those times.
Oh, okay. Do you find it helpful when you do? Yeah. I honestly think watching the video before coming to class would be more helpful than watching it after. Looking at this chart of the integer of X, what in the world what does this say?
It's approaching from the positive direction, so it's going to.
I'm going to what? I'm going to what?
Left.
I'm going to 1
Oh, that's wrong.
from the, I'm going from the right hand side, right? From the right hand side.
So
Is it the positive direction of the graph or the x-axis?
So if this is, so I'm approaching 1 from the positive side. So that's this way. Here I'm approaching 1 from the negative side.
would it approaching X, the limit of X approaching 1 from the positive side, wouldn't that be 1?
It is one.
For good fortune, however, if you were to do so from the negative side, it would be 0.
Correct. So this is 1. What's this?
0.
It is 0, correct. Does that make sense?
Yeah. Can you explain one more time?
Okay, remember that a limit is approaching, right? When x approaches 1. When I'm approaching 1 from the positive side, so here's 1 over here. From the positive side, I'm approaching 1,
Oh, okay.
so it's going to be 1. When I approach 1 from the left-hand side, what's the y?
Here.
It's 0. It's 0 right here.
Is that a closed dot?
It's an open circle, but remember, we're approaching that value.
Oh,
It doesn't
okay.
matter that there's a hole there. We're talking about approaching that value. What about the last one?
Does not exist. 'cause you
Not
can't-
exist because
you-
the
it's a token button, so
sides
it's not
are
that.
different.
Yep, the values are, Kana, does that make sense that this would be, does not exist?
Yes.
Okay,
Both-
Does
both-
not exist if it's just more than one answer.
yeah, if you have more than one answer, then it's, yeah, it does not exist.